So this is the review worksheet, and we're going to be doing some of the inequalities where we graph the inequalities. And remember, when we do that, it's either a dashed line or a solid line. If the inequality symbol does not have a line under it, it will be a dashed line. If the inequality has a line under it, it will be a solid line. Points on the solid line are part of the solution. Points on a dashed line are not part of the solutions. And then, of course, you're either going to shade one side or the other side of the line, and solutions are in the shaded part. So points that are in the shade are solutions. They will make the inequality true. Points on the not shaded side are not solutions. Okay, so if the equation or inequality is in y equals format, then you can decide if it's shade up or shade down without testing a point. If the y's are on the big side, y's get bigger going up, so I'm going to shade above the line. All those points above the line are solutions. If the y's are smaller on the pointed end of the equation, then I'm going to shade below the equation. I'm going to shade down, and the points down there in the shade are solutions. All right, so in this one it says the graph of this equation is shown below. So here's the graph of that equation. But the question is down here. Which ordered pair is in the solution set of this inequality? So what's going to happen is either the bottom's going to be shaded or the top is going to be shaded. Solutions are in the shaded part. 3x minus 5y, 3x minus 5y. 15 on the right, 15 on the right. So this is the line that goes with this inequality. I just got to decide if it's shade up or shade down. Is it in y equals format? No, so I can't know offhand just looking at it whether it's shade up or shade down. But what I can do is test a point. And what is the easiest point to test? Yes, the origin, 0, 0, because it's easy to do math with 0, 0. So remember, x is 0 and y is 0 at that point. If that point is true, then it's a solution, and I'm going to shade up. If I do it and it's false, that means that point is not a solution, so I want it in the white area. I'm going to shade below the line. So let's go do this and see what happens. X is 0 and y is 0. So if I plug in a 0 down here, this is 3 times 0 minus 5 times 0 is greater than or equal to 15. So I plugged in a 0 for the x, and I plugged in a 0 for the y because that point is 0, 0. X is 0, y is 0. 3 times 0 is 0. 5 times 0 is 0. So this whole left side became a big old 0, which is why we do this, because it's really easy on the math. That means 0 is greater than or equal to 15. So this whole left side was a 0, greater than or equal to 15. Is 0 bigger than 15? No, this is false. So that means that point is not a solution. So I don't want to shade this side. This is the side I'm going to shade. Points that are over here in the shaded area are solutions. Points up here in this are not solutions. Now we also need to decide, was that a solid line or a dashed line? It does have a line underneath the inequality symbol, so points that are on that solid line are also going to be solutions. So we're going to go plot these points and see if they fall in the not solution or the solution side. And we're looking for the one that's in the solution. 0, 0, obviously not a solution. 2, 4, if I run 2 and jump up to 4, I am not in the shaded area. 4, 2, if I run over 4 and jump up 2, again, I'm not in the shaded area. 2, negative 4, if I go right 2 and down 1, 2, 3, 4, I am definitely in the shaded area, so that one is my solution. So remember, solutions are in the shade. Number 2, let's see what we have here. Sarah orders packages for her business. It's a lot of blah, blah, blah. I go down to the end and it says where she's going to save money using the second option. So it's not one where I can just go look for a domain or a range or x-intercept or something. I got to read it. So she orders packages from her business. Shipping cost has 2 options for shipping. Option 1, she can pay $2 plus an additional $1.50 per pound, or option 2 is pay $3 per pound. X is the number of pounds that it weighs. So this is like 3 times X, 3 times 1 pound, 3 times 2 pounds, 3 pounds, 3 pounds. This is $2 plus $1.50 per pound. So $1.50 times X, $1.50 times whatever the number is. So if you look at these down here, the $1.50 with the X plus the 2 is on the left side. That's option 1. Option 2, the $3 times X is on the right side. The question is, which inequality represents the statement Sarah would save money using the second option? So I've got option 1 on the left and option 2 on the right. If I am saving money, does that mean this one's bigger or smaller amount of money? Yes, if I'm saving money, this is smaller. So if it's smaller, I want to turn the pointed end toward it. Now, is it okay for it to be equal to it? Am I saving money if they cost the same? No. So I truly want option 2 to be smaller than option 1. So which is the only one that has this inequality symbol that I'm looking for? Yes, it is D. Option 2 is less than option 1. So you may have to do some reading on those, but they're mainly, those inequality ones are just reading and interpreting them that way. So here we have this big old table. So the total cost for X number of tacos at 2 different places. So remember, the first column is your X numbers. This is the Y number for the first equation. This is the Y number for the second equation. So this is a double table. This is X and Y's for one equation. And if I cover up the middle one, that's the X for the X numbers are still on the left, and that's the Y numbers on the right for the second equation. So when you put 2 equations in the graphing calculator, this is what the table looks like. It's a double table. So which system of equations best represents this table? So we want to match this table, and here are my systems. The good news is, are they all in Y equals format? Except for these X equals, they are all in Y equals format. So what we can do is put these 2 equations in the calculator, just plain old graph icon, and go to the table, Control T. If that table looks just like this, when X is 1, the first Y is 4, and the second Y is 350. When X is 2, the first Y is 5, and the second Y is 7. 3, the first is 6, next one is 1050. If this matches exactly, that's the one I'm looking for. So you just take the time and type them in the calculator very carefully and go see which one matches. So go do that if you have not. Now you can't put C in the calculator, but if one of these other ones matches it, I don't need to worry about C because these are in X equals format. So go put A, B, and D in there and see which one matches that table, if any. Okay, hopefully you went and did that, and you're right. B was the one that matched that table exactly. Okay, systems of equations. Remember, that's when we have 2 different equations on one graph, and look right here, we do have 2 equations in this one. So it's going to be a systems of equations. So the question in here is estimate the number of hot Cheeto bags Jamarian bought. So I'm focused on the hot Cheetos. Jamarian bought some bags of Cheetos. Regular Cheetos were $2 a bag. So you see the 2 times the R, that's my $2 times the bag of regular Cheetos. Hot Cheetos were $3.50 a bag. So $3.50 times C is the hot Cheetos. Now, he spent $18. So $2 times the regular bags plus $3.50 times all the hot Cheetos bags. If you add those 2 piles of money together, it equals $18. So that's the equation. They gave us the equation. I don't have to write them. But R is my regular bags and C's are my hot Cheetos. And then he said he bought a total of 6 bags. So my R plus my C equals 6. I'm not having to write them. They gave them to me. All I got to do, anytime you have a systems of equations, we put them in the graphing calculator under LinSolve. So you go to your home key, and from there you look at the Add Subtract icon and click on it. You're in the Add Subtract screen, and you do Menu 3-2, Menu Algebra, and then the second option is Solving a Systems of Equations, because that's what we're doing. Now you can't put R's and C's in the equations, so instead you're going to use X's and Y's. So I'm going to use the X, the R, and I'm going to use a Y for the C. So I'm going to type that in, except instead of R, I use X, instead of C, I do Y. When I do the second equation, it's X plus Y equals the 6. Now, the Y is the hot Cheetos. So when I get done, I'm interested in how many bags of hot Cheetos. Where these 2 intersect, because that's what LinSolve does, it gives me the intersection, there's going to have an X number and a Y number. And I want to know the hot Cheetos number, which is the Y number. So in that intersection, I am looking for that number. Okay? So you're going to type the 2 equations in the calculator LinSolve. As soon as you see 2 equations, just go to LinSolve and type them in. Look to see where they intersect, and your job is to decide is it the X number or the Y number you're looking for. And since I used a Y for the C and $3.50 is the hot Cheetos, that's the one I'm going to pick as the Y number. So go put those in LinSolve and see what the intersection is. Okay, hopefully you did that, and now you're back with me. And the intersection was 2, 4. And of course, we know we're looking for the Y number, so 4. We bought 4 bags of hot Cheetos is what that is telling me. So again, you didn't have to write the equations, you're just putting them in the LinSolve. So here's another graph down here, and there's 2 lines on it, so it's a systems of equations, and generally we're looking for where they intersect. And sure enough, the question is, what's the total cost when both options are the same? And they are the same where they intersect. So that's what we're looking for, is where these 2 intersect. And they intersect right here. So we want to know what's the cost, the total cost. Now this is the time worked, so I don't care about the time worked. I want the total cost, which is over here. So for that point where they intersect, goes straight across and is at $150. So that's the number I'm looking for. It's not A, B, or C, but if you go ahead and scan over to the next page, if I can get my paper to turn. Sure enough, there's D at the top of the next page, so it is D, $150. I know the formatting list was kind of weird. All right, number 6. We have, ooh, look, a systems of equations. So they have written them for me. I'm just picking out the equation that matches the situation. I've got a box containing 22 coins. So how many coins altogether? 22. They are quarters and dimes. Did they use D's and Q's down here? They did, so I'm assuming D's are my dimes and Q's are my quarters, and sure enough, that's what they say. Q's are quarters, and D's are dimes. So if I add all my dimes and quarters together, how many coins are there? 22. D plus Q is 22. D plus Q is not that, so we're going to get rid of C. D plus Q is 22. So 3 of them work for the first equation. Second one is the total value, the money, is $3.50. How much is a dime worth? Dimes are 0.10, so 0.10 goes with the dimes. What is a quarter worth? 0.25 goes with the Q's. So let's see, and it's $3.55. So 3.55, 0.2 dimes, 0.25 quarters, add them together. I'm thinking that works. Let's check the other ones. This one is 10D, not 0.10, but 10. So that's not the one I want. It's got the wrong information. And this is 10 cents and 25 cents, but it's $355, not $3.55. So the only one that matched, B. So we're just matching those equations to the words. Here's that f of -3 again. That is shorthand in mathematics for find the y when x is, what is the x? We're plugging in a -3 for x. So a lot of you like to use the table version of this, which means you're just going to go put the whole equation in the calculator under the graph icon, just like you were going to graph it. Go ahead and graph it, hit enter, and after the graph is in, go to the table, Control T. Once you see the two columns, the x's are on the left, the y's are on the right. We are looking for when x is -3, we want to know what the y number is. That's what that is asking you. It's saying when x is -3, what is the y number? So just go type this equation in just like it is. The graph icon always has f of x equals in there, so you're just typing in the right-hand side, x squared minus 3x plus 2. Hit enter, Control T, go see what it is. Hopefully you've done that. You paused the video while you went and did it, and now that you've come back, let's see, what was this one? Do I have it up over here? It's on this page. This one was D20. Number 9. Let's see, where's 9? Here is 7, 8. Oh, there's 9 over there. I skipped 7. We'll come back to 7 in a minute. 8 or 9. Let's go do 9. So this is the systems of equations, and again, they're intersecting right here. The question is, what is the solution to this graph systems of equations? Well, the solution are points that are on both lines. What's the only point that's on both lines? That point right there where they intersect. And they're ordered pairs. I want the location of that point. So remember, x comes first, y comes second. So the x number is a 3, positive 3. The y number is a -2. So 3, -2 is the ordered pair that goes with that. And of course, that one is C. 7 up here. What is the best approximate solution, if any, for the systems of linear equations below? Remember that poster. If the two lines intersect, the solution is where they intersect. If the two lines are parallel, there's no solution. And if the two lines are on top of each other, right, two lines right on top of each other, that means there's infinite solutions because there's infinite points on top of each other. Parallel lines don't have any solutions. Intersecting lines have one point that's on both of them. So one solution, no solution, infinite solutions. So this is obviously no solution. There are no points on both lines. And that's in your posters in Unit 4. Systems of equations are all the Unit 4 posters. All right, so what's left on this one? Number 10 down here. Write the equation of the line. Well, look at there. It's a lovely vertical line. So vertical is Vux, V-U-X. The slope they asked was undefined because it starts with a U. The equation starts with x equals just a single number. That's what we're looking for. So down here I have, well, it's chopped off on the next page, but x equals what number? X is -3. So we're looking for x is -3, and by golly, it's A on this one. All right, let's see. Number 11, solve for x. Now, we could solve by hand by drawing the line through the equal sign, but we can also do this one by nsolve. I showed y'all yesterday on the calculator how to do nsolve. So you're going to go to the home screen and then go to the add subtract icon. To get to nsolve or linsolve, you go to the add subtract screen. Once you're there, you hit menu and then look for the classroom, which is algebra. So menu 3 is algebra. And then we're going to go to the first option, which is numerical solve. So menu 3.1 takes you to solving a single equation. So you can only use nsolve when it's an equation and it's one equation and only has one variable and I only have x's in here. So when that screen comes up, you're going to type in this equation, 4x plus 2 equals subtract 2x, subtract 4, and at the end put a comma to tell the calculator you're done with the equation, and then type in your variable that you used, which is an x. And then when you hit enter, it'll tell you what x is equal to. So if you have done that one, it was -1. Now that answer is not on this sheet, and I don't even think it shows up on the next one, but x is -1 on that one, just so that you know when you do that. So you might want to type that into nsolve and make sure you can do nsolve. That's a handy feature to have on this STAR test coming up. Okay, here is another solve one. Is it two equations? Yes. As soon as you see a system of equations, you go to LinSolve and put them in the calculator. You want to know if they intersect, what that point is where they intersect. So we go to LinSolve, which is back to the home screen, go to the Add Subtract icon, then type in Menu, 3, which is the algebra, and then 2, because it's solving a system of linear equations. Put in both the equations, type them in. The top box gets the top equation, the bottom box gets the bottom equation, and then hit enter. And it will tell you where they intersect. Now, if it's no solution, it will say no solutions. If it's infinite solutions, it's going to give you a very weird, strange answer with C's and L's and kind of stuff in it, and it just looks really weird. So if you get something that looks really weird with kind of the sort of looking stuff, that's your infinite solutions. If they intersect, it will be an ordered pair. If it's no solution, it will say no solution. So when you put those two in the calculator, I think I did that one. Maybe I did, maybe I didn't yet. Oh, it was infinite solutions, which means those two lines were on top of each other, because it gave you a very strange answer when you did that in the calculator. It probably looks something like this, and that means it's the infinite solution. 13. Now, this is one where they're going to have you estimate where they intersect out there. I really don't like these, and this one I think even has the wrong answer on. I think it should have been 12,300 down here, so if you change this one to 300, it will look much better. But this one was going down 1 over 2, so down 1 over 2 puts me, let me put a little line here and put a little line there. So I went down 1 over 2, and then it's going to go down 1 and over 2 again. So that's where this line is going. It's going right through this point here. This one is going down 1 and over 4. So if I go down 1 and over 1, 2, 3, 4, they're intersecting on that point. So this was 9. This first one was 10. Second one was 11, and this one out here is 12. So they're intersecting on the x-axis at 12, so the x number is 12, and the y number should have been a 300 on this one because it's on that line right there, which is 300. So one way to do it is that way. You could have also tried to write the equations and then put the two equations in LinSolve. You can see the y-intercepts, and you could have found the slope, and done it that way, but sometimes estimating is easy too. Let's see, where are we going on this one? Number 14. So we want to know which inequality represents the graph. Now remember, if this is a dashed line, it's going to have no line underneath the inequality symbol. So this would have been a solid line, so it's not A. This would be a dashed line. This would be a solid line. So A and C are out, but B and D are in the running. Now, they're not in y equals format, so I can't just see shade up or shade down, so I'm going to test this point 0, 0. All right, so 0, 0. If I plug it into the first one, x is 0, and 3 times y is 0, so this is 0 plus 0, so this whole side becomes a 0. So 0 is less than negative 2. Is that true? 0 is not less than negative 2. Negative 2s are to the left on the number line, so this is false. False. So that means this point is not a solution. Is it in the not shaded area? So I'm kind of thinking this one is it, because it should be false. 0, 0 should be false because it's not in the shade. If you want to double check down here, negative 0 minus also this is 0, because if y is 0 and x is 0, this whole thing becomes 0. Is 0 greater than 6? That one is also false. Oh, I hate it when they're both false. So this one's false, right? Let me make sure about that. 0 is greater than 6. Yes, that is false, because that whole side 0, 0. So if they give them to you where they're both false and you don't know which one it is, because they are both in that. So what you have to do then is test another point, or you could truly solve them for y and see which one it's going to be. So if we solve, well, I guess we just go ahead and solve. That's one way to do it. Or we could test another point. I'm looking to see if there's another point in here that I can definitely see. Here is negative 3. I don't know if that'll get to or not. So I'm not sure. So the only other way to do this is truly solve each of these for y. So sometimes you just have to solve for y. So this one, if I subtract 1x on both sides, I'm going to do it over here. This is 3y is less than, subtract 1x. So I subtract 1x on this side, subtract 1x on this side, minus 2. So I've rewritten it. Divide by 3, divide by 3, divide by 3. So the y-intercept, so it's a negative slope, negative 1/3, and it is down 1 over 3, so that makes sense, it is negative. But the y-intercept is negative 2/3. Is it crossing right here at negative 2/3? No, it is not. So it is not B. So which one is it going to be? It will be D. Okay, that was just a mean one. Write the equation of a line going through the 2 points. So all the equations are in y equals format. That should make you smile. So you can one at a time put them in the calculator and check their table. So you put them in the graphing calculator, hit the Control T for the table, and you want to see when x is -4, the y should be -3. And also check the second point. When x is -3, the y should be 2. So you want to make sure they go through both points. And only one of those equations does, so go put them in the calculator and see which one matches the table. Hopefully you did that, and now you come back, and yes, D was the right answer. Don't you hate it when it's the very last one? Okay, we're almost done with this last one. Which graph shows the solution set for this inequality? Well, when you look at this inequality, is it going to be a shaded line or a dashed line? It will be dashed. So F is in the running, G is out. H is in the running, J is out. Now, when I look at these two pictures, they both had the exact same dashed line, so there's no reason to go solve it for y because they're going to be the exact same equation. What I do want to do is one is shaded down and one is shaded up. So what I could do is just test the origin and see which one it is. So let's plug in 0, 0. If x is 0 minus 3 times 0, right? There's the left-hand side. X is 0, -3 times 0. It's less than -6. This whole side became a big old 0, so 0 is less than -6. Is 0 smaller than -6? No, 0 is bigger, so this is false. So that means I want 0, 0 to be in the false area. Is 0, 0 in the false area here? Yes, it's in the non-shaded, so this is my winner, F. Okay, so that kind of caught us up on some of the inequalities and things like that, and we will be back with you guys on Monday to review some more.